This is the first of a new video series on APIs, and we'll look at how to start a new API project. There will be multiple videos, but this video is the most non-technical video in the series. Other videos are more directed at developers and architects. However, this particular video is high level for anybody. By the way, API.cc is the domain I own that is available for development partnerships or to buy if you'd like to leverage this unique domain for your own projects. Check out buy.api.cc. My name is Chris St. John, owner at API.cc. I've worked with enterprise-level APIs, cloud, and startups over my career of 20-plus years. Recently at Nike for 4 years working on APIs and developing and planning cloud solutions. Message me and I can help you with any API and cloud architecture guidance. Contact info in the video description. Let's take a quick look at the summary of what we are covering in this video. Our goal in this video is for the developer and team to understand the purpose of the API and requirements prior to starting development. This video is non-technical. It's for everybody on the team. This is a simplified API starter checklist. And this will help us get started on the right path. 1. Clearly define the use cases. Understand the specific problem or need. 2. Involve stakeholders and collaborators. 3. Prioritize user and dev experience. 4. Great documentation and onboarding. 5. Consistent and intuitive API design with best practices. 6. Error handling and debugging support. 7. Support versioning and compatibility. 8. Scalability, reliability, and performance. 9. Budget cost requirements. 10. IAM security and compliance. 11. Review industry standards and prior art. 12. Extensibility. Plan for future user infrastructure and code growth. Clearly define the use cases for the API. Understand the specific problems and needs that you need to address. There are many different ways of defining use cases. One way I like to do it is to use the 6U workflow. That's the usability workflow I have on systemsarchitect.io. This is basically 6 user-related topics or questions to better define the user needs. First, we look at the user story. You can think of that as the elevator pitch for the API. Bottom line up front in a minute or less. What is the point of this from a user perspective? Next, we have to look at the user roles. And these are the types of users of the API. There could be many types of users. You could have internal or external developers and other users. Maybe a cloud accounting team keeping track of costs. Or perhaps a security team that needs to keep track of your endpoints, and maybe even a marketing team keeping track of metrics. We have to think about all the different types of users so we can plan what we need. Next is user qualities. For example, the location of the users is going to affect how we build out the API infrastructure. If all the users are concentrated in a very small area, perhaps it's just one company, it's an internal API, and they are all in that geographical location, then we probably don't need infrastructure all around the world. The other extreme is that it's a global company, global API access is needed, and we may have to use cloud edge locations or even cloud infrastructure in other locations of the world. Also, we should be aware of usage times and usage rates of the users, and that may vary depending on your use case. User interface and user screens are also very important because oftentimes what we were told explicitly was needed for the API may be missing some data properties, and so by going through the user interface and the user screens, we can easily unearth things that have been missed. Lastly, we need to look a little bit at what the user growth is projected to be. That will help us prepare for future usage, both in terms of rate of request and traffic. And it may also indicate what other types of API endpoints are needed in the future. There are a variety of resources that can help us define the use cases, but usually some of the tools involved include Lucidchart, Figma Design Tool. There's a website called Creately, which helps you create use case diagrams. You can even do Google searches on lists of use case questions, or even check with ChatGPT or Google Bard. Involve stakeholders and collaborators. Get them engaged. Identify the key players and deciders. Find out key pain points and goals of each of them. Confirm the key requirements as you understand it. Identify potential time and process blockers. Solicit other specialists as required. And schedule tech and product team reviews. The pyramid on the right is the request workflow plus the requirements workflow that we use when we're architecting an app, and this can be translated also to APIs. And I have a lot more details about this on systemsarchitect.io, but you'll see at the bottom in the foundation of the pyramid is the 6U user workflow. And then from there we gather our requirements. Once we've gotten our requirements down, we do a review. And then after we've done a review, we usually resolve any issues. They always come up. We figure that out. And then once we're ready for that is the actual development, which we call the realize stage. And then once we've deployed, at least in an alpha version, we do a reassessment and an iteration of all the below to make sure that everything is on track. For the product and tech reviews, only hold a meeting when prepared and confident. Get buy-in from key players prior to the meetings. Validate where each key player stands. Present to the correct audience. Tech and high-level reviews are going to be a little bit different. And finalize the buy-in. And then finalize the roadmap and contract, all pre-development. 3, prioritize user and dev experience. Make UX, DX, and understandability a high priority. Make sure to prioritize user and dev experience for your APIs. Follow API best practices. Have great documentation. Use visual docs, diagrams, and interaction charts. Have an easy quick start and setup for auth and data. Make sure to have good versioning, and make sure your API changes in the future will be backward compatible. Have good error messaging. Make sure to have a reference of all your parameters, methods, endpoints. If your API is complex enough, you may need an SDK. You may need to add additional developer tools. And of course, make sure to have support contacts, chat, and community if possible. Have great documentation and onboarding. Start documenting and onboarding plans early. Great documentation includes documenting business goals, cases, and audience. And then, of course, the main areas of your API, such as having a getting started section, a section discussing the authentication that could be used, sections for endpoints available, request response examples, and error handling. Your documentation can also have technology and systems architecture with diagrams and charts to make it easier to understand for developers how the APIs connect to other systems. And of course, as I've already mentioned, provide an easy quick start guide and tutorial. Have all the parameters described and examples in popular languages if possible. If this is a public API, then definitely give examples in popular languages. There are many different types of API documentation tools available, and I'm just going to cover a few of the common ones right here. First, we have Swagger UI, which generates documentation from your API, and that's using the Open API standards. You can generate the documentation from an API several ways in Swagger. For example, you can create manually a file in JSON or YAML, and you define the API using the Open API specifications. Postman and Insomnia are API tools and platforms that are used by many developers that are very popular for testing APIs, calling APIs to find out what the response is going to be, what the format and shape of the data received is going to be. Then we have online API documentation platforms. These are included in some of the big API platforms such as Kong. There's also a way to use documentation with Postman, both in the tool and the platform. There's other platforms out there as well who give this option. It's a feature of the API platform, such as on Stoplight or Apiary. If you want to build out your documentation portal for your API, you may also want to look at Docusaurus and Gitbook. There are over 60 API design and documentation platforms according to apilandscape.apicene.io. So there's many more to investigate. Make sure you have consistent and intuitive API design. That means naming the endpoints, parameters, and response in logical ways so they're easily understandable and usable. There are a couple really good API design guides that can give you a lot of information about best practices and standards. One of them is on google.com, cloud.google.com/API/design. And this will cover topics like resource names, standard methods used, custom methods, errors, naming conventions, design patterns, and many other things. Another really good API design guide to look at is Microsoft Azure API Design Guide, and that's in the Microsoft Azure documentation under Architecture Best Practices. And that's mostly focused on REST APIs, and it will look at some other things like filtering, paginating data, partial responses, and versioning as well. Error handling and debugging support. Have informative error messages and help developers handle errors. Here are some best practices for helping with error handling. Clear and informative error messages, consistent error response format, HTTP status codes, logging and error tracking, troubleshooting in the documentation, error recovery guides. Make sure to sanitize input data. And of course, make sure to have support contacts available, perhaps a forum or chat. Make sure that you are supporting versioning and compatibility. There will be future changes, and you want to make sure that your API is backward compatible. We're not going to get too technical in this particular video, but just know there are different versioning strategies out there that have pros and cons. Be aware of some of these versioning options. For example, URL-based versioning and header versioning are both pretty popular ways of implementing the versioning. The URL-based versioning is easier, requires a client code update though. Query parameter versioning can be used. That's pretty flexible, and you do need to handle the parsing of that though. And the header versioning is very extensible. It's often used internally, especially. That gives you cleaner URLs, but does also require client code changes at times. And there's also other types of versioning, such as media type and resource-based versioning. We'll go much more into these in other videos that are more technical. Scalability, reliability, and performance. Make sure your infrastructure plans match your roadmap and user needs. This is one of the biggest sections that we're not going to get into all the technical specifics in this video because it would take way too long, and it's even more than one additional video. It's probably several additional videos. But you can see in this table that there are many different types of APIs. There's different benefits and drawbacks to them. There's the REST API, which is widely adopted. It's very popular, but it does have some downsides. GraphQL is often used in mobile apps. It's known for having more efficient data retrieval, but it is a little bit more complex and does have a learning curve to it. There's RPCs, which are used in other applications as well. They have the performance benefits and can use bidirectional streaming. There's webhooks, WebSockets, and even HTTP streams. That's often used in audio and video. Along with these different types of APIs, there are also different types of delivery platforms. We see here that you can start from the simplest instance-based API, and you could use something like Express.js or Flask, depending on your language that you're using. And in this case, you're just basically building the API on an instance. You might have multiple instances. As developers, we often don't even think about it because we are coding a lot or architecting solutions, but there are a lot of no-code and low-code solutions out there that might actually fit some very simple API needs. For example, Zapier and Epiphany are two different solutions out there. You can, for example, connect an API to Google Sheets. There's other automation techniques, and it doesn't require any coding to use these tools. So it's something to look into if you want to save developer time and it's just a simple request. There are many other frameworks that can be used with instances or containers, and it depends on the language and what exactly you're looking for. There's many tools out there. One of the popular ones for Node.js, for example, is Nest.js, and that gives you a full framework that can handle different REST APIs, GraphQL, RPC, and has a whole middleware element and security. And another one is Fast API, which is a very popular Python tool for REST APIs. So look a little bit more at the tools if you need a granular instance or container solution. As you get into many more APIs that you have to manage, or an API with many endpoints, or many users or admins, you may need to go up from the instance and container-based API frameworks, and that's when we start getting into serverless APIs. For example, API Gateway. AWS API Gateway is a fully managed service provided by Amazon Web Services that allows developers to create, deploy, and manage APIs. There's API creation, API deployment, API management, integration with backend services, which is really helpful if you're already in the AWS ecosystem. And of course, they have things like monitoring and logging using CloudWatch or other tools that you can use. This is a very powerful API platform tool that is popular with developers, particularly because of the popularity of the AWS ecosystem and the ease of use. There are many API cloud management platforms out there of different sizes. Some of the bigger ones include Tyke, Apigee, which has been bought by Google, Kong, Azure API Management, and MuleSoft Anypoint Platform. And these offer a variety of features like rate limiting, authentication, analytics, and all integrated into an easy-to-use dashboard that is made simple for API developers. We will be reviewing these in a lot more detail in other videos, so I'm not going to go into too much detail on each right now, and I've left many out, but we'll look at those in another video. Just be aware that there are very specialized API platform management solutions, and those are becoming a lot more popular with developers because of all the features they offer. Another way of determining your API infrastructure needs is to go through the UCROPS principles for a well-architected framework, which I've detailed on systemsarchitect.io. Essentially, this is tailoring your API infrastructure to the needs in all of these categories. And this is derived from AWS Well-Architected Framework, which you may be familiar with, but it does have a few small modifications. Some of the categories we look at when we're developing for this is usability or understandability of the APIs and infrastructure for both developers and users, cost optimization, maximizing the efficiency and cost effectiveness of the systems involved, operational excellence, designing systems to deliver the business value, but doing that in an operationally efficient way where we have continuous feedback and improvement, automation, and of course, obviously, this is the big one that most people would think of right away, performance efficiency. At different levels of requirements of performance, we're able to work with those and adapt to any workload changes and do that in a cost-effective way. And then, of course, security, making sure that we are protecting information, systems and assets through using different security controls, whether that's authentication, authorization, scope, and so forth. And that would even include WAFs or firewalls, and incident response. Budget and cost requirements. Obviously, our options in most cases will be bounded by cost considerations and our budget. There are a variety of different costs that can be incurred, and we can look at some of the different categories here. We have compute, which would be hosting instances, whether those are dedicated, whether they're ephemeral, or even if they're serverless functions. We have networking, traffic. There could be all different types of varieties of network costs. Storage, which would include static assets, databases, and then of course if you're using an API gateway platform, they may have additional costs as well. There may be additional costs for special monitoring or logging that you're using, or special security measures such as a firewall, and then you may need additional developer tools, and then of course one of the bigger costs would also be staffing. In theory, an API management platform should greatly simplify your management of very complex APIs, and that may reduce your staffing and reduce your staffing costs. IAM security and compliance. And this would cover users, groups, scopes, other security measures that need to be taken, and even making sure that you are in line with compliance. Here are some API security features that you should be thinking about before you begin development. Verify the identity of client access. Enforce access control policies to ensure that only authorized clients can perform certain actions or access certain endpoints. Input validation and sanitize input. Use rate limiting to prevent DOS attacks or misuse. Use audit logging for monitoring errors, access failures, and help with any security investigation. Use vulnerability detection and management. And of course, for compliance, make sure that you are aligned with data privacy rules, GDPR, HIPAA, PCI DSS, or any internal policies to your company. Review industry standards and prior art. Review similar APIs and their pros and cons. You can get a great head start by reviewing API standards and looking at examples that are already out there. Review similar APIs to get an idea of their structure and some of the options that they're using. Know API best practices. Study API specifications like OpenAPI. Compare existing API platforms for features. Look at case studies in your industry. Visit community forums related to your API. Model documentation after best-in-class documentation you can find, and seek feedback from other specialists. And lastly, extensibility. Plan for future user, infrastructure, and code growth. Plan for future API expansion and changes. Use modular design so you can easily build on your API. Use versioning and backward compatibility. Use customizable parameters. Research also webhooks or event-driven architecture. This can help you handle much higher rates of requests and response. Use a plug-in architecture so different features can easily be plugged in. Make sure that you have developer-friendly docs, diagrams, and tools, so as you add a lot more developers, they can easily be onboarded. Have API keys and scopes so you can make sure to have different roles. And make sure to plan for user growth projections. And that concludes this video for starting a new API and looking at a checklist to identify requirements. We talked about clearly defining use cases, involving stakeholders, prioritizing user and dev experience, having great documentation and onboarding, using consistent and intuitive API design, making sure to use error handling and debugging support, supporting versioning and backward compatibility. Definitely looking more into scalability, reliability, and performance, and we'll be having a whole video on that, or maybe several videos. Looking at budget and cost requirements. Paying attention to IAM security and compliance concerns. Reviewing industry standards and prior art, and getting ready for the future. Thank you again for watching this video, and visit API.cc.